Hello. Yeah. Welcome to the session. My name is Jafar Shamim. I'm business development for Elastic Block Store. Today we're going to talk about Microsoft and Oracle workloads on Amazon Web Services as more and more enterprises and businesses start running their Oracle and Microsoft workloads on Amazon Web Services. We wanted to take this opportunity to talk about some best practices, some guidance as to how do you think about storage in the context of those workloads so that you can run these applications optimally on Amazon Web Services. So I'm going to go through briefly some guidance around EBS, how to think about EBS as you are architecting your storage platform for these applications, and then my colleagues Abdul and Ulf are going to go through some best practices around Oracle and Microsoft applications. So as you come to Amazon Web Services, you have three choices in storage platforms available to you. You have instant storage available to you on the instances that you'll be running your applications. It's great for temporary files and for applications that can tolerate instance failures. And with the announcement of I2 yesterday, you have seen there's a lot of IOPS you can get on the instance storage themselves with the I2 instance type. The second platform, which is where we're going to focus most of our time today, is block storage. This is the Elastic Block Storage service on Amazon Web Services. They give you raw, unformatted block level storage to you that you can format your volumes, put your file systems on them, run your applications, and it's persistent, and we'll go through some more details around the service. And then obviously there's object storage in the form of S3, highly durable, 11 nines of durability, great for pictures, videos. It's a highly durable media store. So what is Elastic Block Store? The way we like to talk about EBS is it's a service. What we're providing to you is block storage as a service. You ask us for how much storage you want, right? From 1 gigabyte to 1 terabyte volume in size, and we give that to you. And the way we give that to you is by making it available to you in the form of a raw unformatted volume. You do whatever you want on top of that. You can ask for the performance that you expect out of that volume. And then when we give this volume to you, it's already replicated within the same availability zone before we give this to you, so that you have a pretty a durable volume to work with to start off with. And we're also providing mechanisms for you to be able to snapshot the volumes, back up the volumes, restore from the volumes, and metrics to be able to monitor what you're getting out of the volume. Are the volumes behaving right so that you can take appropriate actions? So it's a service that's not just giving you disk volumes, but it's also giving you a lot of services around that so that you can manage and monitor your EBS volumes. So within EBS, we have two types of volumes. One is standard volumes, and the other one is provision IOPS volumes, which we launched last year. So the difference is standard volumes give you moderate performance if you have workloads that do not have any expectations of high performance, file stores, boot volumes, light traffic, use standard volumes. Again, 1 gigabyte, 1 terabyte volume in size. And then if you're running workloads that have expectations of consistent performance, you want to be able to run thousands of IOPS on your application, use provision IOPS volumes, right? I mean, if you're running databases, relational or NoSQL, data warehousing applications, provision IOPS volumes is the way to go. So what are customers running on EBS, right? So like I mentioned, relational databases, NoSQL data stores, data repositories, analytics applications. We have customers who are running applications that go up to all the way up to 96,000 IOPS, 96,000 4K IOPS per instance, right? So you can get 4,000 IOPS per volume, but you can stripe multiple volumes to be able to get a lot more than 4,000 IOPS. So we have a number of applications, high volume applications, high I/O applications running on Amazon Web Services. And here are some examples of customers running each type of these applications. The provision IOPS volumes were designed to give you consistent performance. So when you provision IOPS volume, you're getting is a volume where we give you performance 99.9% of the time over the given year within 10% of what you asked for. So the consistency is the design point of provision IOPS volumes. Here's an example. If some of you were here in the keynote yesterday, Pars talked about how they went to very consistent performance after they moved to provision IOPS. This is their example. Before provision IOPS volumes, they were getting pretty high latency spikes, as you can see in the before provision IOPS graph. And after they moved to provision IOPS volumes, not only did they started getting consistent performance, the latency to the end-to-end latency of the applications went down as well. So let me walk you through some key concepts to understand as you start using provision IOPS volumes. They're important to understand because it'll help you choose the right size of the volumes, choose the right instance types for your applications, and also get a sense of how do you drive the volumes to get the performance that you provision the volumes for. So one of the first concepts to understand is the block size. What we do is we measure the I/O in sizes of 16 kilobytes. So when we say you're provisioning a 1,000 IOPS volumes, you are getting 1,016 kilobyte IOPS. And we'll understand why this is important to keep in mind as we talk through this next few slides. Another key concept to understand is that of queue depth. You can monitor your queue depth in the CloudWatch metrics that we provide to you per volume. The reason queue depth is important is if you're provisioning a volume of a certain size, make sure that you're getting the amount of IOPS that you provision, you have to drive enough I/O to it, and the way to measure that is through queue depth. This slide is wrong. It should say very high queue depth may increase latency. So if your queue depth goes high, your latency will increase. Our recommendation is start from the queue depth of 4 and then tune your application based upon what you want from your disk platform, IOPS, latency. So when we announced provision IOPS volumes, we also introduced another concept called EBS-Optimized instances. It's very important to understand what these provide to you. For those of you who have internal SAN infrastructure or NAS infrastructure with dedicated bandwidth to your storage platform, this is what it's providing you. EBS is network attached storage. If you're not using EBS-optimized instances, all storage traffic is going through the same network as your application and internet traffic. What EBS-optimized instances are giving you is dedicated bandwidth from the instance to EBS. This chart, and this is documented, we just updated our documentation on the website to have this information as well. As you can see, amount of maximum bandwidth and the IOPS each instance can drive. This is very important to know. Let me give you an example. EBS-optimized instances give you from 500 megabit to 1 gigabit per second bandwidth to EBS. What does that mean? If you were to provision 4,000 IOPS volume, you're driving around, again, like I mentioned, each IOP is 16 kilobytes in size. So 4,000 IOPS volume, you're driving 64 megabytes a second if you're pushing enough I/O to be able to get the amount of IOPS you provision for that volume. So if you add two 4,000 IOPS volumes to an instance that has 1 gigabit per second to EBS, you're pretty much saturating that bandwidth. You're getting 128 megabytes a second. If you want more, and a lot of people do want more for the Oracle or SQL Server workloads or other applications, you can use what we call our cluster compute instance types, which have all the way up to 800 megabytes per second bandwidth to EBS. So key concept to understand, this information is available on our website, but choose the instance types based upon the amount of IOPS you think your application is going to drive. Also keep in mind, it's a very flexible platform. If you feel an instance type is not the right instance type, you can easily move to another instance type by stopping the instance and moving those volumes to another instance. So we talked about this, right? You have to choose the right instance type. What we mean by avoiding throughput saturation is monitor the throughput to EBS volumes. If you have more than, for example, 4,000 IOPS volumes, you're not going to get anything more if you add the third volume. So make sure you're monitoring these metrics for per volume on the instance type that you have attached these volumes to make sure that you're not getting into a performance bottleneck. I mentioned snapshots as a very easy way to make your volumes more durable. When you create a snapshot, the data from volumes is moved over to S3. So that's one use case, and we highly recommend people use snapshots to make your volumes more durable. But a lot of our customers are using it for other use cases as well. They use snapshots to duplicate the volumes, right? Expand the size of the volumes, and move volumes from one region to the other. A lot of times customers use snapshots in combination with CloudFormation templates to be able to duplicate complete environments from development to test to production. So it's a very useful utility for you to use. There's some key performance concepts to understand with snapshots. The right snapshot is affected a little bit when you're snapshotting a volume. So what we recommend is snapshot a volume during off hours when there's not a lot of I/O traffic, and snapshot often because we only move incremental changes to S3, so snapshots are faster. So with that, I'm going to ask Abdul to come and talk about Oracle, keeping in mind all these things that we spoke about and how you can use those concepts to run highly optimized Oracle workloads on Amazon.
Good morning, everybody. Last day of reInvent, wasn't it 3 exciting days? A lot of new announcements. Who really liked everything we announced here yesterday or the day before? All right. And who really liked Postgres RDS? Something that a lot of people were asking for a long time. My name is Abdul-Sait. I'm a solutions architect focusing on migrating enterprise workloads to AWS. I work quite a bit with Oracle and Oracle technology. So I thought I'll tell you a little bit about using Oracle on AWS in the most optimal way. How many of you are actually running Oracle? How many of you are Oracle customers? Wow, that's like 3/4 of the room. And how many of you are running some Oracle workloads on AWS today? Oh, wonderful. So we have many people who want to do it, right? So let's get started. So why run Oracle on AWS? Over 20 years, I've done a lot of Oracle application implementations for my customers before coming to AWS. So after coming to AWS, one thing that I figured out is AWS totally simplifies building Oracle environments on AWS for your enterprise workloads, whether it is applications, whether it's just databases, whether it's totally integrated environments like your ERP systems, your HR, payroll, which obviously includes database, and your middleware for integrations and multiple applications together all working with each other. Everything becomes so much easier on AWS just because of the nature of AWS, the scriptability of the infrastructure, the ease of cloning one instance, and like Jafar mentioned, taking the snapshots of your EBS volumes and moving them to S3 and then reusing them to recreate the environments many times. Because unlike the regular web application development companies, enterprises normally would have the same environment recreated multiple times, right? You'll have sandbox instances, patch instances, development, unit test, integration test, regression test, UAT, production copy, you name it, 8, 9, 10, 11 environments. And normally most of these environments look very similar, right? When you do patch testing, you want to do patch testing on an environment that looks similar to your production. Otherwise, there's no point patch testing. The difference is the kind of servers you would use in a patch environment will be much smaller than in your production environment. So think about how painful it is doing in your own data center. Now, you need all the hardware to do it, and you have to keep installing and configuring so that all of these look similar. Whereas when you come to AWS, you do it once, you create AMIs out of it, you take snapshot of your EBS volumes, you create CloudFormation templates to set all this up, you are done. Every time you need a new environment, all you have to do is launch that CloudFormation stack with different parameters for the instance types that you want, right? So AWS makes it simpler and makes it easier. And the cost of implementing all this drastically comes down just because of these reasons. Most of these kind of enterprise application implementation run anywhere from 18 to 36 months. That has been my experience, right? And a major part of that implementation, when you get started with, is capacity planning and sizing. And you want to know how much disk that you want to buy, what kind of servers you want for the database, what kind of servers you need for the application server and web server, because you don't want to fall short. And so you naturally over-provision a little bit, but the guys who actually let the money out won't let you over-provision too much, right? So it's kind of like a balance. Normally you hire consultants to do it. That itself is like a 3-month exercise for capacity planning. Then you go through the procurement cycle based on your company's policies, get 3, 4, 5 quotes, go through all of that, find out who are the best people to supply this to you. Then you get your hardware. When it gets to you, you figure out some of that is not what you ordered, so you kind of like, talk to them. Finally, when that part is done, that itself is like a 6-month cycle, right? Then you go through all these things that I mentioned before, setting up all these different environments, configuring them, making sure they are working right, cloning data, replicating data. So if you take an 18-month implementation cycle of your project, you can understand a lot of this totally goes away with AWS, right? There's no procurement cycle here, no budgeting cycle there, no capacity and the capacity planning or sizing. You pick, you do like a 3-day TCO and sizing exercise instead of 3 months. Pick the instance types that you want, pick the EBS volumes that you want. You get started with it, and you figure out, oh, this instance is not good enough for us. Big deal. It takes 3 minutes to switch over to a bigger instance, right? Or for application servers, you start with 3 application servers. End of the month, when you run your payroll cycle, everybody panics. Spin up 30 more application servers. It's probably going to cost you like $150 to run all of that for 1 day, right? So AWS drastically reduces the cost and totally changes the equation of how you do these things. Here are some of the products our customers are, Oracle products our customers are currently running on AWS, which obviously includes Oracle Database. Oracle Database you can run in 2 ways on AWS. One, you spin up your own EC2 instance. Now that EC2 instance looks just like your own on-prem server in your data center or in your office. And you install Oracle on it, configure it, do whatever you want just like you are doing today. Or you can use our managed service called Amazon RDS-for-Oracle, which is a fully managed database. You make a couple of clicks or make a few API calls. You get a database magically appear with the best practices already built into it, configured to ready start using it right away. So you can use either one of the 2 ways. Many people like using RDS for certain workloads like dev, because you need only a small size database and there's not too much interaction or tuning that the DBA wants to do there. For enterprise workloads, many customers use their own database on EC2 for production workloads. So for production instances, they'll be running their own Oracle instance on EC2. One reason for that is RDS supports only up to 3 terabytes. So if your database is bigger than 3 terabytes, you want to run the database on your own. All the Oracle database tools like DataGuard, Active DataGuard, Golden Gate, Streams, all this, again, is supported on AWS, works very well. A lot of customers use it today. When it comes to enterprise applications, a lot of people are using eBusiness Suite. I've seen more people using PeopleSoft and JD Edwards on AWS. Then there are people running ATG, Web Center, Hyperion, OBIE, all kinds of different Oracle applications and software. Anything that is not directly tied to a particular kind of hardware, like Solaris for Sun servers, anything other than that from Oracle runs perfectly fine on AWS. One key part of running your Oracle workloads on AWS is the licensing, right? Most of you already have licenses. And if you don't, you want to know how to get licenses to run this stuff on AWS. We don't sell licenses for any Oracle software except for RDS. For RDS, you can get pay by hour license for RDS database. So that's one option that's available. Other than that, you have to bring your own license for AWS, for Oracle. And all existing Oracle licenses are fully portable to AWS. And I think probably it's the simplest for Oracle because there's nothing you need to do. Basically, you just need to make sure you are in compliance. So if you have a 16-socket processor, 16-socket license for on-prem in your current data center, make sure you are running on an instance that is equivalent when you come to AWS. And Oracle uses a 0.5 core multiplier for enterprise licenses on AWS. So if you pick an instance that has 16 cores, multiplied by 0.5, that is 8. So Oracle calls it 8 sockets. So if you want to run Oracle database on a 16 virtual core EC2 instance, you are going to need an 8-socket license. So this is exactly the same as any Intel servers. The mapping is a little different if you are coming from like Solaris or AX kind of platform. So let's take a look at some of the very common architectures for implementing Oracle applications on AWS. You probably already know about VPC. When you're running any enterprise workload, always run it within VPC and make use of the capabilities, the features that AWS provides you, like multiple availability zones. When you do high availability on-prem, today many people have implemented high availability on-prem for their production applications. But when you do high availability, it's a very good thing, you should all do that. But today the way you do it is, though you have 2 servers, so if one server dies, the other one can pick up, you're still in business, they're all sitting in the same data center, right? So if something happens to a data center, you don't have high availability anymore. Whereas AWS provides you the ability or something what's called multiple availability zones. An availability zone is totally independent from another availability zone. Whatever happens to one availability zone doesn't affect the other availability zone. And the network latency between these two is very low. So make use of this, use multiple availability zone for your HA architecture. So here we have a VPC spread across 2 availability zones, a primary and a secondary. And in this 2 availability zones, I'm setting up 3 subnets. So I have 2 private subnets. So anything that's a private subnet can be accessed only by other servers or other instances running within the VPC, nothing from outside. Then we have a public subnet where my web servers are going to go. This is, again, very similar to the network topology that most of you are used to for enterprise applications. I put my primary Oracle database in the private subnet, and I put, this architecture is kind of like for Oracle eBusiness Suite, but it applies to any 3 or 4 tier enterprise application. It's pretty much the same, right? So for eBusiness Suite, there'll be a concurrent server. For PeopleSoft, there won't be a concurrent server, there'll be a batch server. So just terminology difference, otherwise it's the same. So I have 2 application servers here hooked up to the same database, and I have a web server that's actually connected to the application server. So that is our one setup, right? So now what I'm going to do is replicate this to the other availability zone. Now I have a high availability. This is the simplest setup. For your development environments, this is what you're going to do, right? Maybe you won't even have 2 instances in the private subnet. You'll have just 1. for your development environment. But when it comes to production, you want to do this, so you have high availability, right? Now, you see I have two databases, but you cannot use two databases at the same time for one production environment, right? So what I'm doing is I have two databases, the second one as a standby for the primary database, and replicating from the primary to the secondary using DataGuard or Active DataGuard. I suggest DataGuard or Active DataGuard, but you can use, Golden Gate or other third-party tools like DB-Visit or SharePlex or things of that nature as well. DataGuard comes free with Enterprise Edition of database, so probably you don't want to use anything else. Then for the web server, I'm setting up a ELB to load balance between those two web servers. So when users come to the web server to access the application, it's load balanced between two availability zones, two web servers, and then it goes to the right application server from the web server. I attach a NAT instance. NAT instance is for whatever we have in the private subnets to be able to access the internet. The private subnet is totally closed up. Whatever you put there, nothing can access those instances from internet, and those instances cannot access anything outside. So if you, for example, if you want to apply patches, if you want these server instances to be able to pull patches from Oracle support or whatever else, you want the NAT instance to be available there. I set up a database backup in S3. So see, you have a S3 bucket. Oracle has this wonderful utility called Oracle Secure Backup Cloud Module. So the way Oracle Secure Backup Cloud Module works is it works as a plugin for RMAN. So how many DBAs do we have here? Do we have any DBAs? Good number of DBAs. So you all know about RMAN, right? All of you use RMAN for backup? Normally, people use a tape backup mechanism to eventually back up and move the backup outside the premise, and use RMAN to back up to the tape. But RMAN actually doesn't know anything about the tape. The way RMAN is built is with a plug-and-play architecture. So RMAN writes to a pluggable driver for the tape assembly, and the driver takes care of writing it to the tape. It works the same way here. What Oracle did is they wrote this plugin for cloud. So all that is happening here is you switch out the tape assembly driver with the Secure Backup Cloud module. So now your data ends up in a better place, right? What better place than S3 with 11 nines of durability? And normally when people back up to the tape, people are very happy. But when they have to restore, they're not really that happy, right? But here, the data is available to you whenever you want. You back up for 6 months. All the 6 months backups are available to you at the moment's notice for you to pull up. A lot of people use Archival to, again, archive this data to Glacier. So that's what I'm using there. I'm using RMAN plus OSB to back up to S3. One great thing about this OSB is nothing changes for your DBA. You don't need to learn anything new. You are still using the same RMAN to back up. So that is kind of like the basic architecture for an enterprise application, right? Now there are a lot of other things you can do here because of the capabilities of AWS, elasticity and scalability. You can scale up and down the application server or web server, and you can add more servers, right, to take up more load. Now I have added another web server. So now we have 4 web servers. And if you want to do more processing, you have more processing load, you can add more application servers, right? Any number of application servers that you want. Or what you can do is you can put them in what's called auto-scale groups. And specify some parameter saying, oh, if my CPU load goes up this much, add 1 more node. So it'll automatically scale up and down depending on the demand on the system. Now, one thing to keep in mind here is in this whole architecture, when I talked about scalability, I was mostly sticking to the web server and the application server layer, right? We are adding more and more web servers, splitting it up into multiple availability zones. We are adding more and more application servers. But when it comes to database, it's the same single database. Everything, it's kind of like a bridge, right? You have this 18-line freeway where everybody is cruising at 90 miles an hour, and then you come to the 2-lane bridge where now you have to slow down. So it doesn't matter how fast you were coming before. When it comes to the database, there is no other way than to slow down to get there, right? So if you look at this whole architecture, it's extremely important to optimize everything at the database level. So the performance of your whole system is going to depend on the performance of the database, right? So we want to do everything possible to optimize what's happening in the database. So let's look at how we can do optimization on the database level. When it comes to database, you already know probably the most critical thing is the storage. So if you optimize storage, you optimize the database. So now what we are doing is we are still keeping the 18-line freeway up front, and we keep widening the bridge, so it can take more and more traffic. So go with the right kind of, first to start with, go with the right kind of instance types for your database. Like, just want to remind you what Jafar mentioned before. Choose only EBS-optimized instances. You never want to do anything else. Choose only EBS-optimized instances for your database. And always use PIOps volumes. So here did I skip any slides? So here what I'm doing is I'm taking multiple PIOps volumes and striping them together. So we can get like the cumulative advantage of the number of IOPS we have. It's like a chariot, right? In a chariot, you have like 8 horses. You want to, it'll be a good idea to line them up and in the same way and tie them up, right? You don't want them going in 4 different directions. Now, when you have 4 horses versus 8 horses, you have more horsepower, right? Your chariot goes faster. Same concept here. You get multiple volumes, and multiple volumes again becomes important based on the size of your database. The largest EBS volume that you can get is 1 terabyte. So if your database happens to be 12 terabytes, you're not going to be able to use just one EBS volume. You want to get multiple EBS volumes. So when you get multiple EBS volumes, it's a very good idea to stripe them together. So this is what I call a standard enterprise class database architecture, where you have 2 databases, 1 primary and 1 standby. And unlike what I showed you in the application architecture for the e-business suite, now we moved it a little bit further right as well. We have a DR setup there, which we call a pilot light architecture for DR. So you see in the DR setup, which is not in another availability zone, but in a totally different region. So one of the other things that AWS makes available to you is accessibility to one of these 9 global regions just sitting at your desktop. Isn't it cool to be able to sit in Las Vegas and launch a database instance in Singapore? Right? I could never do that before. So this is pretty cool. So you set up your primary and your secondary environment databases here, your primary and standby in the same region, so you can fail over if something happens to the database. And then you'll have a DR in a different region. So if something totally goes wrong in a particular region, you can fail over to the other region. Now, let's say we take 10 EBS volumes, right? Jafar actually showed you that nice chart with numbers and everything, and we picked the largest possible EC2 instance, and we lined up all these EBS volumes. We lined up 10 EBS volumes. 4,000 into 10, we'd get 40,000 IOPS, right? That is good enough for most enterprises, for most workloads. But for certain workloads, that is still not good enough. People need a lot more IOPS than 40,000. So how about 300,000 IOPS? So how do we get 300,000 IOPS if that is what you really want? That is when you start using what's called the ephemeral disk or the instance storage, right? So some of the instance type we have, which used to be only 1 instance type till yesterday, the high I/O instance, it has 2 terabytes of SSDs in it. Yesterday we announced a whole bunch of new I2 instances. There's one I2 instance that gives you about 6 terabytes of local SSD, right? So that means you can have a database up to almost 6 terabytes in the local SSD. And this will give you about 320,000 IOPS. That's a pretty darn good number for any kind of workload that you have. But the problem with having your data there is this is volatile, because it is in the instance. If your instance goes away, you stop and start your instance, you reboot your instance, your data is gone, right? So that is why we want to have replication there just to protect your data. So if you look at this architecture, what I have done is There are actually 4 databases in this picture, right? We have one primary database, and then another standby in the same availability zone for a very quick failover. If something happens to your primary, because in the same availability zone, you can fail over very quickly, and that second database actually uses PIOps, right? It uses EBS volumes. The first one I'm talking about on the top, where it says data volumes, it's actually using instant storage. Whereas the second one, it actually uses EBS volumes. And we are replicating in real time using Oracle Data Guard. So both of these databases are going to be in sync all the time, right? So if something happens to your instance storage, your instance goes away, it fails over right away, and it's available. And if something happens to the entire availability zone, it fails over to the other availability zone, and you are good, right? And if something happens to the entire region, then you'll fail over to your DR region, you are still good. So this is like a very, really elaborate, highly available architecture that could, replace many of the, rack implementations. So the reason I laid it out like this also is for fast failover. So if your primary fails now, you are failing over to a standby in the same availability zone, which is going to be very quick. And if the availability zone fails, it's going to take a little bit more time to fail over to another availability zone. Then if the whole region fails, a little more time to fail over to the other region. So we covered most of this. One key thing I always want you guys to remember is just using provisioned IOPS is not good enough. Though that is what I want you to, so this is like a picture I want you to keep in your mind. Just keep seeing that thing keep coming back to you. PIOPS, PIOPS, PIOPS. Wake up in the middle of the night thinking PIOPS, right? We have a bunch of documentation that actually says use PIOPS for databases and probably use standard volumes for other things. I think it's because when we got started, we are a very cost-conscious company. We always want to cut down costs for our customers. So we didn't want to tell people to pay a little bit more money to use PIOPS for everything. If you're happy with standard IOPS, use standard IOPS for other things. Use PIOPS for database, right? But I would say don't use standard IOPS for anything. If you're an enterprise-class company, that is chump change for you. It doesn't cost you anything. And the most important thing is, when I was putting together these architectures, I actually did some costing exercise. We have a thing called Simple Calculator. You go there, you plug all this in, it'll tell you how much it's going to cost you. I was really surprised and figure out that in some of these cases, PIOPS cost me less than the standard volumes. I don't know why. That's how it turns out. So PIOPS for everything, whether it is for your data volumes, for your redo log volumes, for your, whatever flash recovery volumes, anything that you use as storage for your enterprise application, use only PIOPS. So do you guys want to see this one more time so you can remember? All right. And always use EBS-Optimized instances. Jafar explained it really, really well. Because if you're not using EBS-Optimized instances, you're not really getting the benefit of PIOPS. These are network-attached storage devices, right? So how much ever is the performance of the storage device, you are still throttled by the network. What EBS-Optimized instances do is it reserves a capacity, a channel, only for EBS subsystem, for the I/O subsystem. So if you're not using EBS-Optimized instances, your same the network connection is used for everything. So if you're doing a lot of other things in your application, the consistency of performance you get from your I/O subsystem is going to really suffer. So you go with EBS-Optimized instances, and if you look at our website, you can see even within EBS-Optimized instances, there are multiple levels. Some are 500 megabit, some are 1 gigabit, some gets you the whatever you can take away from the 10 gigabit connection. So especially for database, go with the largest class instances. That gives you 10 gigabit connection. And for other like application server and whatever else, you can use smaller instances. But for storage, always use PIOPS. I don't want to flash it one more time. And make use of the ephemeral disk. Even if you're not shooting for that 320,000 IOPS, you're probably going to be happy with EBS-based database. That is what I recommend you use in most cases. Only when you want extremely high performance out of your database, you go with ephemeral, you go with your instant storage. For most of the normal database use cases, you'll be going with EBS-based database. And stripe together PIOPS volume so you can always get better performance, right? And even if you're not using the ephemeral disk, the instant storage for actual data volumes, you can use for temporary files, for temporary table space. So make sure you make use of it. So it's in smaller instance types, in non-I2 instance types, the local volume is not SSD. But still you'll get good performance because it's right there. It's not going over the network, right? If you guys are not using CloudFormation today for anything, I would suggest you start learning it and start using it. CloudFormation is key for any enterprise migration and enterprise workload. It's like magic. It lets you create things out of thin air with just one click, and lets you design and devise the way that you want your hardware and let other people make use of that code. So if you're writing CloudFormation, this is what you will do to attach those multiple volumes, right? So here I have 3, 6, 7 volumes. No, yeah, 7 volumes altogether and 5 volumes for the data volume. So I'm attaching all those 5 volumes together from EBS volumes, and then I'm installing grid control. This is for Oracle. I'm talking about Oracle, right? So to be able to stripe your PIOPS volumes, you can use multiple tools. If you're running on Windows, Windows has a built-in capability to stripe storage. So you can make use of the Windows capability, which Ulf will talk about in more detail. Or if you are using Linux volumes, you can use a bunch of open source tools available. But I would strongly recommend for Oracle, you use Oracle ASM. I found Oracle ASM to be the most high performant and easy to use when it comes to rating the disk array for Oracle database. One great thing that Oracle ASM does is, as your database grows, let's say you start with 3 terabytes or 4 terabytes of EBS volumes, and you need to add more volumes, you can just add more volumes to ASM stripe, and ASM will automatically balance the load. It'll keep synchronously moving load over, so you don't get hot points, right? So you install grid control, and you set up everything for grid control, and you install grid control. So while you're installing grid control, you're also asking ASM to stripe the volumes. I really like seeing when people take pictures. It makes me feel like people really understand what I'm talking about. But they're going to send you the whole deck next Wednesday. So there's no need to memorize this either. But the deck is just going to have the slides, right? And if you guys really miss my face, probably this is going to be available on YouTube as well. So we install grid control and stripe the volumes. And then when you install the database, this is what we need to do. Say storage type is equal to ASM, storage type ASM, and disk group name, or the group name I gave for the ASM disk group, right? So this is all you need to do when you're installing Oracle database to use that disk group we striped using ASM. You don't need to use striping. You can actually, when you create Oracle database, you can create multiple data files, right? So if you attach 10 volumes, you can create each data file in each volume. So you're still making use of all the volumes, and you can have the storage for your database. But the striping this way and using ASM is going to give you the best performance and best balancing. Then comes database backup. So we covered, your availability for your application architecture for database. Now you have your application running, your database running. The next thing you want to do is make sure you back up your data properly. And I mentioned this a few times, using S3, using OSB, the Oracle Secure Backup module with RMAN to backup. One other thing that you could do is take snapshots. So if you have a pretty small database size, let's say your development database is 100 gigabytes. So you can just snapshot the whole volume. In that case, you are not going to use striped multiple volumes. You'll probably have one single 100 gig volume. You can snapshot that volumes and restore from the snapshot whenever you want if something goes wrong with the database, or you want to roll back. You create a snapshot from your production, you bring it to development, scrub the data so your developers can use that data. Depending on the kind of industry you are from, many different industries have different regulatory requirements to archive data. So a lot of people use Glacier to archive data for a longer time. Now I'd like to hand over to Ulf to see what we can do with Microsoft workloads. Thank you very much.
Great. Thank you very much, Abdul. I realize I'm standing between you and lunch, so I'll speed it up a little bit. And shall we go right to a demo, or shall we talk a little bit first? Okay, where do we have the clicker? Right there. Wow, I mean, thinking about all the Oracle workloads running on AWS seems quite complicated. Definitely not for the faint of heart, looking at all these pictures and architectures and the complexities involved. When we talk about Windows-based workloads on AWS, we think about it in a very simple way. It's your solution at your scale, powered by AWS. The full power of AWS, all these services, all these pieces of ancillary technology from a Windows perspective, ancillary technology coming into the fray, being the deployment services in form of CloudFormation, PowerShell CLI, being it storage options in form of the EBS service, which we focus on here today, or additional storage option in form for Archival, S3, or even Glacier. And well, this is stating the obvious, but it is important to keep it in mind, right? Storage performance is key in all your Windows-based workloads, be it a normal, an enterprise SharePoint farm that you set up for high availability to deliver globally to your global workforce, or be it Exchange servers. Here, the architectural drawing that I use as an example is certainly a very small implementation, but if you think about it, these implementations, when you get into 10,000, 15,000, or 20,000 users, depending on mailbox size and the storage requirements, these can become easily 12, 14 mailbox servers and a handful of client access servers in front of it to service these requests and service the storage need for online and archival storage of these Windows-based solutions. So planning and sizing your deployment becomes paramount. It is super, super important. And we know from experience, from many projects that we have done, that our customers have done, that, that you can really size as though you would deploy for a physical data center. For examples, the tools that Microsoft publishes are tried and true for a long, long period of time in market. You are familiar with them. An Exchange role-based calculator is a very reliable tool to get you to a very good candidate design for your deployment. The capacity planning worksheets for SharePoint are an excellent place to start to think through all the aspects of the storage needs you may have in your environment. However, in all this, you want to think and consider the performance characteristic of a shared compute network and storage environment. These are the things that are different from the on-premise world, and this is what you need to have in the back of your mind. Provision IOPS and provision IOPS associated with EBS-optimized instances based on the results of your calculations and taking into account what we have learned earlier from Jafar about the block sizes, We think about 16K block sizes per IOPS. In the Exchange environment, that would mean Exchange optimizes for 64K writes, depending on version. Older versions also 32K writes. So that means you actually have to multiply in a 64K case by 4 in order to provision the right number of IOPS for that specific solution. Deploy the storage solution that you want in the context of your overall stack. And we define stack as a collection of related AWS resources. Deploy those storage components, the EBS storage components, using the tools you're already familiar with. AWS tools for Visual Studio, for example, gives you the familiar Visual Studio environment, and you use the CloudFormation plugin to write CloudFormation to set up these stacks. These can be arbitrarily complex and large, to the degree that you can stand up complete enterprise SharePoint farms in about 2.5 hours with a single click. Or you use the AWS command line for Windows PowerShell in a similar fashion. So from the AWS CloudFormation, you can see here, this is just a sample snippet, but the both things do actually the same things. In CloudFormation, you deal with the declarative nature of the language, so you have very straightforward declaration of your resource, the resource of a certain type, AWS EC2 volume, that's an EBS volume in that case. You set certain properties. In this example, I've chosen a certain mailbox size. This is for an Exchange deployment. So I ran through the Exchange calculator, got exactly my sizing right, and that's the way how I provision my mailboxes. And on the other hand, you see in a very compact way doing exactly the same thing through the Windows PowerShell CLI. There are distinct differences between those two deployment technologies. When you go via CloudFormation, you have the full power of the service, the workflow engine, everything that takes care of understanding what needs to come first, what needs to come second, and so on. And in Windows PowerShell CLI, you have high efficiency, super fast API execution against the infrastructure to deploy what you need. Configuring storage for maximum performance. We heard many times about striping. In the Windows world, the tools and techniques that you're familiar with are exactly the same. Being it up to Windows Server 2008, that you go through the old and trusted DiskSpark utility to actually set up your striping and take the volume information, the volumes that you have attached to it, rename them so you can actually know this is my mailbox volume number 1 and this mailbox volume number 2, or this is my temp volume, this is my page volume. Or doing then in subsequent versions, from Windows Server 2012 on, where Microsoft provides us with great additional PowerShell tools around the disk management module that you can use to do this in a way more compact way. And also with a little bit more intelligence behind it, where you can actually loop through the number of volumes that are assigned and make intelligent decisions about it. Just the difference in implementation, but I wanted to point them out to you, what you have available to you. There should be nothing new here. The key thing is that you understand, and when you walk away, that you actually haven't learned anything new, because it is not new. It is just the way you are used to from an on-premise world. You just apply it to those standard Windows-based instances running in AWS. Talk a little bit about deployment best practices here. Key pieces in all Windows-based workloads, as it is true for Oracle workloads or any other database workloads, removing of I/O contention is often a paramount requirement to get maximum performance. That means for us, having in many of the instance sizes ephemeral storage available to you is a great thing to utilize for temp files, for page files. Yes, because the ephemeral nature of those volumes, you have to understand that you probably have to write a little bit of code that you put into the startup script. in case the instance would get terminated and you would need to provide the right settings, whatever you have done there earlier on in the initial provisioning. But it's available to you, and it is high performant for these type of tasks, specifically in the Windows world. Striping for maximum IOPS, absolutely. If you find a highly transactional SQL Server database and you need 4,000, 8,000 or more IOPS, do stripe them. It's highly efficient. The performance that you also get out of these stripe volumes and out of those database volumes is very reliable. The tools that I mentioned earlier that you used to with regards to calculating your IOPS requirement in the example of Exchange, if you run tests and use, again, the standard tools, something like JetStress, to test your deployment before putting it into production and exercise the storage subsystem, if you properly provision the IOPS based on your calculations, we have found in tests that JetStress actually returns exactly the IOPS within a tenth or less than a tenth of an IOP. Very reliable, very predictable for your deployments. However, you want to understand that latency is an important factor. You saw the chart that Jafar put up with regards to the instances and the throughput that the instances have to your storage. If you calculate in an Exchange environment a large-scale deployment, you deal with things, standard overhead that is there, like background database maintenance requirements. The calculator gives you a number. If you see this number get close or even exceed the total megabits per second in throughput to the instance, you know you would be already in trouble. So you want to consider these and then think through your architecture. What you need to do to properly scale out, how many volumes can you reliably attach to the instance to not get into any type of latency issues. So you want to think through the parameters that you have at your disposal, utilizing the results you get out of your planning and capacity planning exercise. And last but not least, like for all these deployments, you obviously always want to validate what your planning does for you. We found it very reliable. Your situations may be different, but you definitely want to validate using, again, the standard tools that are there. So last but not least, I wanted to just give you also, not just talk about these things, but I wanted to give you a quick demo of actually a highly available cluster running SQL Server always on in AWS. And with some help, we get switched over here to my demo machine. Just great. Let's make sure it's coming up. Awesome. So for that, I just log into an environment. Actually, this is an environment we have stood up on Tuesday during a full-day boot camp that about 60 attendees here at the show participated in, where we front to end deployed a whole enterprise data center, Microsoft data center in the AWS cloud. And one part of this was deploying actually Windows Server failover cluster with two cluster nodes that synchronously set up for automatic failover. And so what you see here on your left side of the screen is a little application that we've written. We call it the blaster. It's all it does is just blast the database with row inserts and it's written against the database availability group listener. So I start this right now. And we start seeing some row inserts happening. Don't look at this from a performance perspective. It's there to visualize what's going on. So you see information about which of the nodes is currently the primary replica. You see that all nodes are up, and you see that this is a a file share witness configuration. So the third node in the quorum is a file share witness set up here. So on the other side, on your to your right, I just use the failover wizard out of SQL Server Always On and failover this database. So as we see in the application that inserts the row, the connected server is server failover node 1. It's active. I'll connect to node 2 that I want to fail over to. Again, I'm doing this right now in a controlled way. The same thing would happen if I would just terminate the instance and the cluster would totally take care of that. So I just connect to it here from the wizard, connect to the database. Next, and when I click finish, you will see in the little application in the Blast app that actually the row inserts stop for a moment while behind the scenes the cluster fails over, the DNS reassignment happens. And so you see, unable to access the database, failover is happening, failover was successful, and in just a few short moments, the application will continue to work, and it continues the row inserts. And now cluster node 2 is the primary replica, and the IP address for the primary cluster node 1 that was previously primary node is now offline. So, and with that, I'm at the end of this part. I think we're here for a couple of minutes for Q&A. We are around here, and maybe some closing words from Jafar.
Yeah, thanks for coming. I know we're running out of time, so if you have any questions, please come over here. We'll be here for some time. We also have a product manager from EBS over here as well. So any questions on EBS, Oracle, Microsoft, on AWS, please come and ask them, and also feedback that you may have.
Yeah, and also please remember to fill in the survey